Hi, all of you. Welcome to the online video presentation on Geotechnical Lab Experiment. In that, today we will discuss regarding determination of field density by sand replacement method. So, very first, the procedure how we are going to conduct it based on the IS standard 2720 part 28. What is the aim of the experiment? To find the bulk density and dry density of a soil in field condition. What are all the apparatus required? Very first, the sand pouring cylinder of about 3 liter capacity. It is mounted above a pouring cone and separated by a shutter. You can observe over here. And then a metal tray with a central hole, a calibrating cylinder of 10 centimeter internal dia and 15 centimeter internal depth. A glass plate, then the excavating tools, the container which is used to find out the water content determination, and then the metal tray, balance, ISUs of 600 and 300 microns. Finally, thermostatically, very first we have to calibrate the bulk density of sand. For that, what we have to do, we have to find out the volume of the calibrating cylinder. That is equal to area into height. Area is nothing but pi d square by 4 into height is h. Diameter is 10, so it becomes pi by 4 into 10 square into height is 12.73. Finally, the value it comes 999.8 centimeter cube. Approximately volume of the calibrating cylinder, it becomes 1000 centimeter cube. Note down this value in the tabular column. And then how we are going to conduct the experiment, you can observe over here. Very first, we have to ensure that weighing balance is showing 0, and then place the sand pouring cylinder on the weighing balance. Note down its empty weight. Afterwards, fill the sand pouring cylinder with calibrating sand within about 10 mm gap from its top, and then weigh the sand pouring cylinder with sand and record its weight, that is W1. After that, after noting down the weight W1, keep the sand pouring cylinder on the calibrating cylinder and then open the shutter. Open the shutter, allow the sand to freely fall into the calibrating cylinder till the calibrating container is filled, and then close the shutter. When there is no free movement, then you can close the shutter, and then note down the sand pouring cylinder weight W2. You can observe over here weight of the cylinder plus sand before pouring into the calibrating cylinder, that is W1 is equal to 7476. Mean weight of the cylinder plus sand after pouring into the calibrating cylinder, that is W2 is equal to 5610 gram. After note downing the sand pouring cylindrical weight, place the sand pouring cylinder on a glass plate. Open the shutter, allow the sand to run out, until there is no further movement. Sand takes place. Close the shutter and remove the sand pouring cylinder carefully. To note down what is the collected sand left down on the glass plate and record its weight, that is W3. So finally, mean weight of the sand in cone portion, that is of pouring cylinder, W3 is 436 gram. Weight of the sand to fill calibrating container, that is W suffix x, that is W1 minus W2 minus W3, that gives you 1430 gram. And bulk density, that is gamma S, is given by the Ws divided by the volume of the container, that is 1430 divided by 1000, that gives you 1.43. After finding out the bulk density of sand, we have to find out the in situ dry density of soil. For that, what you have to do, expose an area of about 450 mm square on the soil surface where the test is to be performed. And then we have to trim the surface to level it using a scraper tool. And then you have to level it. After that, you have to place the metal tray with a central hole on the prepared ground. and it has to be firmly fixed. Prepare a hole in a ground of dimension approximately equal to dimension of the calibrating container. Collect the excavated soil carefully and record its weight W. It has to, W. And then next what we have to do means we have to place the sand pouring cylinder concentrically over the excavated hole. You can observe over we are placing the cylinder concentrically on the excavated hole. And then what we have to do next, we have to open the shutter, allow the sand to run out into the hole with when there is no further movement of the sand takes place in the cylinder, and then close the shutter. Remove the cylinder from the excavated hole and weight the sand pulling cylinder with remaining sand, that is W4. For take a small soil sample specimen from this soil for moisture content determination as per standard procedure. Weight of the wet soil from the hole WW, it is 2000 gram. Weight of the cylinder plus sand before pouring W1, that is 7476. Mean weight of the cylinder plus sand after pouring into the ground into the hole W4, that is 5596. Weight of the sand in hole WB, that is W1 minus W4 minus W3, that gives you 1444 gram. And then volume of the hole, that is V suffix H, that gives W by B, weight of the sand in hole divided by gamma suffix S, that is bulk density of sand, that gives you 1009.8. And then you have to find bulk density gamma B, that is WW divided by WB into gamma S. WW is the weight of the wet soil, WB is the weight of the sand in hole into gamma S. 2000 divided by 1444 into 1.43, that gives you 1.98. Water content here in this case, it is W is equal to 13.62. Dry density is given by gamma D, that is D is equal to bulk density divided by 1 plus water content. Bulk density is 1.98 plus divided by 1 plus water content is 13.62 divided by 100, that gives you 1.13. 1.98 divided by 1.13 gives you 1.74. Repeat the same operation in same area, different places to obtain average result and record all the observation in the proforma or in the tabular column as shown. And then you have to find out the average dry density, that is 1.74 plus 1.74 plus 1.76 divided by 3, that gives you 1.75 gram per centimeter cube. Average dry density is equal to 1.75 gram per centimeter cube. And finally, I would like to thank our beloved principal, Dr. B.V. Ravishankar, our HOD, Dr. P. Prasanna Kumar, and teaching and non-teaching staff. And I will convey my thanks to one and all, presented by Sandesh Enyu. Thank you one and all.